In today's lesson, we're going to see how our understanding of linear functions and graphs can help us understand some real-world situations. We're going to start by looking at a scatter plot. A scatter plot is just a way to represent real-world data. Now, not very often will real-world data fall on a perfect line. You can see in the graph below here, this represents the number of hours worked and the money earned for 5 different days last week. You can see that the dots are sort of scattered a little bit. They sort of look like they fall along the pattern of a line. We can maybe draw a line through them, but it's not a perfect line. Suppose we wanted to answer this question of how many hours we should work to earn $200. So we can see that each of the points that are already plotted are showing us the amount of hours worked and the dollar amount earned. So one day last week, working 6 hours, we earned a little more than $80. Another day last week, also working 6 hours, we earned a little less than $120. Now this might be a type of job where it's based on maybe tips, working at a restaurant, where you can work the same amount of time but earn slightly different amounts of money depending on maybe how busy it is and how many customers you have. So if we want to make an estimate here about how many hours to work to earn $200, we could draw what's called a trend line. So I'm going to start down here below and kind of do my best to draw a line that I'm going to say that fits the data points well. And by saying that, I mean it's not perfectly going to go through all the data points. I'm kind of looking for something that goes through the data points evenly. Maybe the same number of data points are above the line as are below. Let me show you an example of something that would not be a very good trend line. Might be a line that looks something like this. Even though it goes through the middle of the points, it actually perfectly passes through one of them. That doesn't really show the pattern or the slope of most of the points. Okay, so I've gone back and drawn the better line through. So we can see that $200 is right here at the top of our graph. And if we look at our trend line, go straight down, it looks like it might be somewhere in between 8 or 9 hours. Would just be an estimate, just a prediction based on the information that we were given. So we're going to look at a few more examples of scatter plots. Sometimes there's a clear relationship between the variables, other times there's not. A scatter plot can visually help us to see that. So looking at the first graph here, we're looking at the amount of traffic on the highway compared to the time it takes to drive to the zoo. And it looks like as the traffic increases, the more traffic there is, the more time that it takes to get to the zoo. The next situation here involves the number of times that a pencil is sharpened compared to the length of a pencil. Notice how we have kind of an opposite pattern here. The points are going down because the more times you sharpen your pencil, the shorter the pencil will be. In the last scatter plot, we have the time it takes to get to school compared to the height of the student. Notice how there's really no relationship here. The points are just all over the place because it doesn't matter how tall you are to get to school. Time it takes to get to school is probably going to be more related to your transportation form that you use to get to school, how far you live away from the school. So this one really shows that there's no relationship at all. And so correlation is the word that we use describing how the variables relate to each other. And there's really 3 types of correlation, so positive, negative, or none. So if you take a look at the first 2 pictures here, both of these have a negative correlation. It's stronger if the points are closer together, and it's weaker if the points are a little bit more spread out. But either one, we could draw a trend line through the points. That trend line would have a negative slope, so that's going to be negative correlation. Now if we look at the last 2 pictures over here, we're going to see that both of these are positive correlation because the line that we would draw through them, the line of best fit, would have a positive slope, and again it's stronger if they're closer together, it's weaker if they're further apart. Now the last one, there's just no correlation. We really cannot draw a trend line through this. There's really no relationship between what we're comparing. So going back to these 2 pictures here, we see the first one is another example of a positive correlation. This is a negative correlation, and The last picture has no correlation. How has the average movie ticket price changed over your lifetime? So here we're going to actually look at a table of data. We're going to make a scatter plot, and we're going to draw in a trend line by hand. We're then going to figure out the equation of the trend line, and then we're going to use that trend line equation to help us make some predictions. So in setting up our scatter plot, let's start by listing our years across the bottom on the x-axis. Let's actually start by putting 2004 right here at this very first position. Then we've got 2006, 2008. So we've got several years here, but it looks like it's jumping up 2 years in 2-year increments. So we'll go ahead and continue labeling these all the way until we get to 2020. All right, and then let's put information about the price over here on the y-axis. So the lowest price is close to $6. The highest price is close to $9. So let's actually start labeling our y-axis here with $6 even. And going up, if we have each increment represent 20 cents, then we're going to go up 5 spaces, 1, 2, 3, 4, 5, to get to the next dollar amount. So I'm not going to label every single one in between, but this would be like 620, 640, 660, 680, and then we're at $7. Let's go up 5 units again, 1, 2, 3, 4, 5, to get $8. 1, 2, 3, 4, 5, to get to $9. Perfect. All right, so now we're going to start plotting the points from our table. So in 2004, the price was $6.21. I'm going to actually switch colors here so that these stand out. So it's going to be a little bit more than $6.20, so that's right about here. In 2006, it was $6.55. So here's $6.40. This is $6.60. So it's going to be probably right about there. In 2008, it was $7.18. So that's just a little less than $7.20. In 2010, it was $7.89. So right here is $7.80. This is $8, so it's going to be right about halfway there. Then in 2012, it was $7.96. So that's just below $8. 2014, it was $8.17. So that's just below $8.20. 2016, it was $8.65. So we've got $8.20, $8.40, $8.60. So $8.65 would be about here. In 2018 and in 2020, it was $9.11. So it's going to be about halfway between $9 and $9.20. So we'll put both of those data points right about there. So in answering some questions about what we see in the scatter plot, we can see that it looks like there's a positive correlation. The data points don't perfectly fall on a line, but if we were to draw a line through, that line would have a positive slope. So for this next part, if you have a ruler or even just the edge of like a folder or a planner or something or a notebook, you can grab that to help you draw a perfectly straight line. I've got a straight line tool here that I'm going to use. And to draw a line of best fit that kind of does a good job passing through the data points, I might have to do a couple. But I'm going to start right about here, and I can move my line a little bit, but I think I'm going to do, adjust that up, maybe right about there. So again, it doesn't perfectly pass through all the data points, but it kind of fits them. Some are above, some are below. We want to think about visually, thinking that it's kind of even, sort of going through the middle of the points the best it can. So that's our trend line. The next part, we're going to now write the equation for our trend line, and we're going to use the help of looking for, we just need 2 points that our line passes through. So I'm actually going to use the very first point, and then I'm going to use this middle point right here. And I'm going to write the ordered pairs next to each point, and I'm getting those values exactly from the table, the data table. So we've used the 2004 point, and then we're also using the 2012 point. If your line was drawn slightly different than mine, you might have two different points that you're using, and that's perfectly fine. Our trendline equations might not be exactly the same, but they'll end up being really similar. So now we're going to use some skills that we've just been practicing in the previous lessons. We've got 2 points that our line passes through. We can start by using those 2 points to find the slope of our line. So we're going to subtract the y values, y2 minus y1, so that's going to be 796 minus 621. And then on the denominator, we're going to subtract the x values. So we end up getting 1.75 over 8. And we're going to go ahead and divide that. So in our calculator, let's do 1.75 divided by 8, and we get our slope, which is about 0.21875. All right, so now we know our slope, and to get our equation, we are going to put in a point that it passes through. Now, something that we're going to do that's very common when we're dealing with data that involves years is to do a little bit of sliding the scale. What I mean by that is taking these x values, instead of using the full year, 2004 or 2012, which those are very big numbers, we can do something like this, conversion. That was the word I was trying to think of. Converting the x values to have them represent something simpler, like x represents the number of years since the year 2000. So instead of using 12 for this x value, instead of using 2012, let's use 12. And for this one, instead of using 2004, let's use 4. Now what's interesting is that for this denominator part, when we were initially finding our slope, it doesn't matter if you use 2012 and 2004, or if you just use 12 and 4, you're still going to get a difference of 8. So it's not going to change anything about our slope. But it is going to slightly change the final answer that we get for our equation. So we're going to start by putting this into point-slope form. Eventually we'll turn it into slope-intercept form. And it doesn't matter what point we use. Let's just use the first point when we put it into point-slope form. So we're going to do y minus the y value of that point, so that's going to be 6.21, equals our slope, and I'm going to round the slope to be 0.22. When we're rounding, if you look at the 8, that's bigger than 5, so it's enough to push up the 1 to the next value. So we'll just say 0.22 times the quantity x minus the x value of the point. So remember, instead of using 2004, we're just going to use 4 because x is going to represent the number of years since 2000. I don't know why I wrote 2008. It's the number of years since 2000. Okay, so now let's turn it into slope-intercept form. So we're going to go ahead and distribute the 0.22. So 0.22 times 4 is 0.88. And then we'll go ahead and add 621 to both sides. So our final equation in slope-intercept form is 0.22x, and then let's do 6.21 minus 0.88. We get positive 5.33. Okay, so we're going to say this is our final answer here for our trend line equation, based on the line that we drew by hand. Okay, so now we're going to use our trendline equation to make some predictions. So we're going to start by predicting what we think the average movie ticket price would be in the year 2024. Now, because we defined x to be the number of years since the year 2000, we're not going to be plugging in 2024, we're just going to be plugging in 24. So our trendline equation, 0.22 multiplied by x, so we're going to plug in a 24 there, and then add 5.33 onto the end. We get an answer here of a predicted ticket price, average ticket price of $10.61. So this is an easy prediction to do, just converting the x value to 24 and then just plugging that in for x. The next question is wanting us now to predict the average movie ticket price, predict when, so predict the year when the movie ticket price is going to reach $11. So now we're just setting up our equation slightly differently. Y represents the movie ticket price, so we're just going to set that equal to 11. And this time we're solving for x. X is the number of years since the year 2000, so that's going to tell us an idea of the year. So we'll solve this equation like we normally would. Let's go ahead and start by subtracting 533 from both sides. 11 minus 533 is 567. And then we'll go ahead and divide both sides by 0.22. That will get x by itself on the right. And 567 divided by 0.22 is approximately 25.77. So if x is the number of years since the year 2000, we could round this up to 26, and we can say, well, it would be approximately the year 2026. Now, for both of our predictions, let me go back here to the graph. We could also look at the trend line on the graph. So let me actually add a few years here at the bottom. So let's add 2022, 2024. Our scale on the side, 1, 2, 3, 4, 5. There we've got $10. We can kind of look at this line and we can see it's actually still going a little bit for 2024. So we can see that that estimate of 1061 is probably pretty accurate with our graph. And then if our graph is a little bit taller, we can continue that line further and see, okay, $11, and then go down and see what the year is. So either visually from the graph or algebraically using the trendline equation, the trend line is very helpful for us to make predictions.